This topic is about the balanced force technique. This is a method of using files by hand invented by Dr. James Rohn. And it's the most powerful way I've ever used a hand file. I can cut more dentin with more control around severe curvatures with this method than rotary. In fact, this method of using a hand file can get you out of rotary problems. I use the balanced force for initial negotiation. I can talk about it on a different topic, but suffice to say, if I'm having trouble getting an 8 or a 10K file to lengthen a small curved canal like an MB2 of an upper molar, all I have to do is use a 15 or a 20 with the balanced force technique, 3 or 4 millimeters away from those other files, and these files that were hanging up in the canal now passively drop to length. This is to relieve rotary files. Okay. Nobody ever said rotary files can shape any root canal. They can't shape every root canal. The more clever we get, the greater range of anatomy we can use these in, but when you start having S curves like that, especially those that get really tight at the end, your rotary files are going to be just fine until about here. They're going to hang up. If you just use the balanced force technique with a couple of nickel titanium K files, everything's going to be sized up and the rotary file will have less binding and be more likely to get to length. In some cases, we're going to use it to finish the shape with, for instance, a hand GT file. Okay, so what is the technique? The technique is one that is fairly much the opposite of what I was taught in dental school. If we look at a K file in cross section, they're square or they're triangular. Okay, sizes 06 to 15 look like this. Sizes 20 on up are usually triangular. We need strength in the small files and we need flexibility in the larger files. Well, traditionally we've used quarter turn pull, as it's called. And basically what we've been taught is to thread this file into the canal a quarter of a turn and then pull on it. So we thread the blades in and we pull, cutting that dentin that has been engaged by the flutes. A couple of problems with this, however. First off, is ledging. Huge. Turns out when you have a canal that curves apically, as they do, when we rotate a file in a clockwise direction, the blade is pulling itself upward and it will want to head in this vector. It's not going to naturally go around the curve. And that's how we get this hourglass preparation in our final shape. Okay? That's what we don't want to have. That's one issue. The second issue is it's terribly inefficient. Okay? So it's dangerous, but at least it's not very effective. Okay, so what Jim Rohn figured out is, and we'll do all this on a triangular blade, just since I'm not going to do balanced force on these smaller files. What Jim Rohn recommended was the same quarter turn engagement stroke or less, okay? So quite often it's like an 1/8 of a turn. Okay, or we're talking 45 to 90 degrees. And if you're in a severely curved canal, do not engage the blades to a full 90 degrees or you could twist them off. We set the blades, and if we were to take a look at the canal right now with this file into it, we would see that the blades have embedded in the canal wall. Okay, I call this the engagement stroke. or setting the blades. Okay, so we've threaded the file. It's a screw thread, it's a helical thread like a screw, and we've threaded in the canal 45 to 90 degrees. The file has moved into the canal. Okay, and I mentioned this when I talk about using all files. When I activate this file, which is in the engagement stroke, I'm going to look very carefully at the stop and the reference point or any sight line I need, and I'm going to make sure that when I do the engagement stroke, the file physically moves into the canal. If it doesn't move into the canal, I need to get it out of there and do something different. That's a different topic. Okay, so this is the point at which we would have done the quarter turn and pulled the file out, and it's that pulling it out that makes the blades cut away from the inside of the curvature. Instead, we're going to apply relatively tremendous force into the file apically, and we're going to push on the handle and we're going to rotate a full 360 degrees. Okay, so what does that look like? Well, here's the blade ends. We set the blades, and then with no pressure, if I push on the blades when I engage this, then I'm going to get the blades over embedded. And again, if they're over embedded, I could twist them off. So I lightly set them, no apical pressure. Now I'm going to put pressure on the handle because I'm going to rotate it counterclockwise. If I don't put the pressure on the handle, the file just slips out, threads in, slips out, and I'm actually tapping a screw thread. So if you don't do the cutting stroke effectively, you'll see a shape in a root canal. It looks like it's threaded. Okay, so what's going on here? The blade advances some small amount, and then while we're at that position, we're going to rotate the file counterclockwise 360 degrees with serious apical pressure on it. Okay, this is a blade, sorry. And by holding it in place and rotating this file counterclockwise, the blades will center in the root canal. Okay, so if the blades are around a curve in a quarter turn pull, the blade wants to go like this. In a counterclockwise rotation, the blade wants to exit the canal. We're holding it in there so it can't, okay? It's not moving coronally or apically, so eventually this tip will make the cut and you'll feel it give. When you thread the blade in, and you reset your hands, put a good apical force on it, and start rotating, you'll feel it get tighter and tighter and tighter until it gives a little bit and you feel a click, and then it gives again and you feel a second click, and then it's smooth. Usually that occurs between 180 and 360. Okay, and that's the cut. If you rotate less than 180 degrees, it's not going to cut. You're just going to wind it, and then it's going to spring back to its original position. So, to reiterate, triangular file, set the blades quarter turn clockwise, and then with apical pressure, a full 360 counterclockwise. This is what it looks like, and this is a technique sensitive method. Apical pressure, and this is time. Okay, so here's the engagement stroke. No apical pressure. Now we go to the cutting stroke and we put all this force in the file and we rotate, 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 and it gives. And the pressure goes away because it's cut. And then we set the blade again. We put apical pressure on it, and we rotate, 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 and between 180 and 360, somewhere in there, it's going to give as those blades pop to the next groove, cutting half of the land between the grooves, and then the next click is when you cut the last part of the dentin. Okay, if you put too much pressure on the engagement stroke, okay, if we put too much pressure on the engagement stroke, we over embed the flutes, and so instead of embedding, say, 2 or 3 millimeters, we start embedding, you know, half the file because it's over engaged, then you're not going to be able to cut through there. You're just going to twist the blade off below it. If you have the situation where you've over engaged the blade, you're past 180 and you're not feeling any give, just release some apical pressure, let the file back out 1/4 of a turn, reapply pressure, make that cut, go to the previous position, make that cut, and you'll be good. I think that the force on these instruments is so great that using stainless steel is really just not the best way to go. You don't want to use nickel titanium K files. You don't have to use fresh ones every time, but the flexibility and the toughness will serve you well with this technique. What else do I need to mention?
Any
Do the balanced force technique is, are you right or left-handed? Funny question, huh? The reason that I asked this is because when I started teaching the balanced force technique in my 2-day courses, we realized that, I don't know how it came about, but we realized that the left-handed clinicians understood how to do the balanced force technique the first day. The right-handed clinicians didn't really pull it off until the second day. And as we looked at this and tried to deconstruct what's going on here, it's another example of the anatomic imperative. Okay, so here's the deal. Right-handers have their power stroke this way, clockwise. Left-handers have their power stroke counterclockwise. Which way are we turning the file to cut? Counterclockwise. Which way do we want to avoid over-engaging the file? Unfortunately, in the direction of right-handers' power strokes. So right-handers tend to over-embed the file, and they tend to not make the cut, so to speak. Because in making the cut, we've set the blade, hopefully in this case not too far, we've set the blade, we apply an apical pressure and we start turning it, and if I haven't held the handle of the instrument correctly, then I'm going to run out of fingers. Okay, so if I'm holding the file like this and I start to counter rotate, my wrist won't go very far, and that just happens. I get about, you know, maybe 100 degrees of rotation. It's never going to cut. So for us right-handers, we need to go ahead and set our wrists, grab the blade, and we need to put the handle on the side of our index finger because we can roll around there 360, 720. We can roll that handle all the way down the side of your finger and get the full 360. Left-handers, it works great because they have a weak but ideal engagement stroke, and they have a powerful counterclockwise cutting stroke with a conventionally cut file. This is a payback for all the problems left-handers have with normal scissors, I guess. Okay, so in motion, it's complex technique. You have to get every one of these little steps perfectly. So I recommend that you learn it step by step. So first, put your fingers lightly on the file, 45 to 90 degree engagement stroke with no apical pressure. Let go of the file. The engagement stroke is done. If you're a right-hander, turn your wrist this way, put the file handle on the side of your index finger, and now apply pressure and don't let go. Most of us want to apply pressure at the start and then we kind of let go as we rotate. You got to hold that all the way to the end. So you apply the pressure, you turn it, turn it, turn it, turn it, turn it, and you feel a click, click, and you're done. Don't pull the file out, you just let it rock right back into the canal. I actually move my body back to remove the apical pressure. I reset my fingers, push on it, cut, rock in, push on it, cut, rock in, push on it, and cut. And you'll see my body actually moving. It's kind of goofy looking, but that's how, you know, I apply force through my torso and my arm and my hand.